All right, folks, back with another kinematics example, another basic one. So this one is acceleration, but I've added in a negative direction, so we get a chance to actually work with the negative directions. If it's not negative, you just don't put the negative signs in, and it all works out well. So, car is traveling west at 144 kilometers per hour when the driver sees a road construction sign ahead, deciding that speeding through a construction zone isn't worth it. She slows to a velocity of 90 kilometers per hour west. The car's acceleration while stopping is 3 meters per second squared. A, how long does it take to slow down to the final velocity? And B, how far does the car travel while slowing down? So, for those of you that like to highlight, let's highlight. So, traveling west at 144, then it slows to 90 kilometers per hour west. The acceleration is 3 meters per second squared. We want to know how long and how far. So, was the car initially traveling at 144 or was it initially traveling at 90? So the car is traveling and then slows down to 90. So let's just write down what we have. We could draw a car if we wanted. I don't know if I can draw a car very neatly here, but let's just try it. So there's my car. Not the prettiest thing, but it's a bigger back tires on it. So that's the car. And the car, oh, that's not what I want. Undo that little bit of highlighting. The car was going initially, and I always like to draw pictures. So the car was driving initially. It was going 144 kilometers per hour in the west direction. So it's going in that direction. That's kind of northwest, so kind of west. And its final velocity was 90 kilometers per hour. But in both cases, they were traveling west. So remember that we need to put a negative in here because the negative indicates the west. Sorry for the messiness. Indicates west. So we've got a negative over here. Remember, we can't leave in kilometers per hour, but we'll deal with that in a second. The acceleration is 3 meters per second squared. The natural tendency is to make that a negative, but remember, if the velocity is this way and you're slowing down, then the acceleration is in the opposite direction. So this is still a positive acceleration. And we want to know how long does it take, so we're looking for the time. And then we'll be looking for the position. So, let's write down what we have. So, our V is negative, sorry, this is V, this should be V naught, yep. So this is negative 90 kilometers per hour, which is the same when you divide by 3.6. Negative 25 meters per second. The V naught is negative 144 kilometers per hour, which gives me negative 40 meters per second. And your acceleration is plus 3 meters per second squared. And we're looking for time. All right, so because we're looking for a kinematics formula, these are our variables that we know and are looking for right here. So let's look at our formulas. I've brought them over here, just cover them up for the moment. And we are looking for time. They all have time in them except for this one. So this one's automatically out because there's no time. We have these two with time and this one with time, but we're changing our velocities. This one indicates average velocity, so let's get rid of that one. And so it's come down to these two. And I want time, and I don't have distance, so I'm just going to be this one right here. So let's just plunk this up here. V equals V naught plus AT. The final velocity was negative 25. Remember, it has to be meters per second. That's the key to this. The initial velocity was negative 40. The acceleration was 3. And the time is unknown. That time, a little neater. Let's make it. All right, so I need to get the t by itself, so I'm going to move the 40 over. So negative 25 plus 40 equals 3t. So that's going to give me positive 15 equals 3t. And then, of course, I divide by 3, and I get 5 seconds is my time. So it took 5 seconds to slow down. So obviously they weren't slowing down really quickly. 5 seconds is a long time to slow down. So 5 seconds was the time to slow down. Pretty straightforward. If you get a negative here, you probably got your acceleration in the wrong direction or your velocity. So you get to double check that. All right, that's part A. Part B is how far does it travel while slowing down. So I want to know how far is asking for x. So let's just erase my draw throughs here. Look at them. So I want to know x. This one's out because we just used that one. We don't have a constant velocity, so it can be either one of these. Your choice. I chose to use this one right here because I have the velocities and then the acceleration. If I use this one, it'll still work, but I've taken my time as a calculated value and put it in. So if I messed up part A, I'm gonna mess up part B. So for B, let's use the v squared formula. A little tight for space, so I'm just gonna put it up here. I'm gonna erase this. My drawing took too much space. So we're gonna use v squared equals v naught squared plus 2a x minus x naught. The x naught doesn't tell us, so we're going to assume that's 0. Final velocity, negative 25. And we're substituted in, so it goes in brackets, that's squared. This is negative 40 squared plus 2 times acceleration of 3 times x. Negative 25 squared is 625. 40 squared is 1600 plus 6 times x. Going to bring this to the other side. So I'm going to subtract it. So that's going to give me negative 975 equals 6x. And divide by the 6. And I should get negative 162.5 meters for x. You're probably asking yourself, well, why do I have an x value that's negative? That's not right. Well, remember that we're traveling in this direction, traveling the west direction. So our displacement, or how far we've gone, also has to be in the negative direction, which makes sense now. We've gone 162. So if this position here were 0 degrees on a number line, that would be a negative value. So again, any questions? Email me, pop in, see me. Hopefully we can clear up anything you got. Otherwise, remember, change it to meters per second and watch out for those directions. So that'll help. Those kind of things right there. Great. Thanks.